Okay. We have discussed about heat and what is heat energy and what are the mechanism of internal particles of a material and what is the temperature and those kind of things were discussed in our class 1, and we have defined what is heat energy and what is temperature. Then we have discussed what happens, what can be happen to an object when the heat energy is supplied to that object. So, accordingly, we have discussed when a heat or when a heat is supplied or when a thermal energy is supplied to an object, initially that object absorb heat, and what will happen? Initially, what will happen, Puti? Can we discuss the thing? Tackle again. When we supply heat energy to an object, if that object absorb heat, what will happen first? What will happen first? What can you do? I need answers. I need answers. Tackle again, man. Very quick again. Okay, ready? Resolu? Shashwida? Shashindra? What will happen? That's it. Yeah, temperature will increase. Temperature will increase due to what? Due to what reason, Puti? Temperature increases, yes, yeah. But what is the reason for that? What is the reason behind that? Yes, that is the answer. That is the answer. Yes, yes, Puti. You have to understand that thing. When suppose now this is a this is an object. If we supply heat energy, to this object, what will happen first? The internal particle of those objects will absorb this heat energy. Puti. They will absorb this heat energy. Once they absorb that heat energy, what will happen? Their kinetic energies increase. Their kinetic energies increase. And that is the thing, or that is the first observation we can make. And so, as kinetic energy increases, internal energy may will increase. That is obvious. But remember, the first thing happen is once the heat energy is supplied, that energy will be absorbed by those particles, and due to that reason, their kinetic energies increase with it. As a result of that, internal energy increases as well as temperature also increases. Puti. Okay. Because you know, temperature depends on kinetic energy. Temperature depends on kinetic energy, internal kinetic energy. Temperature depends on internal kinetic energy of those particles. Therefore, when the internal kinetic energy of those particles increases, temperature increases. We can observe that thing. Externally. We can sense that thing externally. We can sense the temperature of that object increases. So what is the reason behind that? Yes, sir. Reason is due to absorption of heat, the kinetic energy increases. As a result of that, temperature increases. As well as internal energy. Okay. Then when then when we supply heat energy furthermore, kinetic energy of those particles increases further. Then there will be a point where the kinetic energy of those particles cannot bear by intermolecular bonds. Intermolecular bonds cannot bear that kinetic energy. Those particles have that much of kinetic energy. That kinetic energy cannot bear by those intermolecular bonds. Then from that point onwards, what will happen? Intermolecular bonds start to break. They start to break up because they cannot hold those particles because they have that much of kinetic energy. Therefore, from that point onward, intermolecular bonds start to break. So initially, the entire heat supplied, initially heat supplied is totally utilized to increase kinetic energy. But from that point onward, the supplied heat fully utilized to break intermolecular bond. As a result of that, supplied heat will not be used to increase kinetic energy. As a result of that, supply heat will not be used to increase kinetic energy. Actually, the supply heat is used to break intermolecular bonds. As a result of that, intermolecular bonds break. They will be break. But although we supply heat energy, that heat energy is not used to increase kinetic energy. That means kinetic energy remains constant during this process. So we cannot observe a temperature increment during this process. But remember, although there is not a temperature increment, although we cannot observe temperature increment, this material absorbs heat. That material absorbs heat. That heat is utilized to break bonds. As we cannot see or as we cannot feel that heat energy, we call that heat as latent heat. So due to that heat, the bonds break. As a result of that, the state of this matter can be changed. It can be changed. That means if the initial state is a solid, if the initial state was a solid, then it will become as a liquid. Okay. Right. Now, this material is totally converted into another state. So once after this conversion, if we supply further heat, now this is a fresh material. Because this solid material is totally converted into another state. Therefore, now this is a fresh material. So as a result of that, this material will act as a fresh material. Therefore, if we supply heat furthermore, that heat again is utilized to increase kinetic energy. Again, again these particles in this state, absorb heat energy and start to increase kinetic energy. With it. Therefore, initially this one is this material was in a solid state. So if we supply heat, what will happen? Putin? Kinetic energy of this particle increases. As a result of that, temperature of that particle increases. Okay. Then what will happen? This particle will come to a certain point where this increased kinetic energy cannot be backed by intermolecular bonds. Then at that point, those intermolecular bonds start to break. Therefore, from this point onward, supplied heat is used to breaking bonds. Intermolecular bonds. And no change in kinetic energy. No change in temperature. Then, so after that, bond breaking relevant to that phase change will be over today. So after that, this solid material will be fully converted into the liquid material. So this is a phase change. Therefore, this solid material will completely converted into a liquid material. Now, if we supply further heat energy, further, it is converted into liquid. Okay. So if we supply heat energy further, heat. This is a liquid. Now this will act as a fresh material. Then energy, this heat energy absorbed this heat energy is absorbed by those particles. This heat energy is absorbed by those particles, and what will happen? Their kinetic energy will be increased. Now, particle absorb heat energy and their kinetic energy will increase. Actually, after full conversion, this material will act as a fresh material. Again, supply heat is used to increase kinetic energy. Okay. Therefore, what will happen? When heat is used to increase kinetic energy. Therefore, again, temperature will increase. Again, temperature start to increase. So during this phase check, temperature is a constant. Temperature is a constant. No change in temperature. No change in temperature. Then, okay, what will happen? Then again, these intermolecular bonds come to a limiting condition. Limiting condition means now, as a result of this, as a result of increment in kinetic energy, again, those intermolecular bonds cannot bear the motion of the particle, cannot bear the motion of the particle. They will vibrate or they will move very fastly. Therefore, these intermolecular bonds cannot bear that motion. Then again, Pute, there will be a certain point, those intermolecular bonds start to break. There will be a certain point where the intermolecular bonds start to break again. Start to break again. Then what will happen? Then what will happen? Again, intermolecular bond breaking through. Breaking intermolecular bonds. Therefore, the supply heat is totally used to breaking intermolecular bond, no change in kinetic energy. Therefore, no change in kinetic energy. Therefore, no change in temperature. Is that clear? If you got this one, please raise that. Clear on question. I need response from everyone. Thank you. Then what will happen now? This is a liquid namute. What will happen? The entire intermolecular bonds, all the intermolecular bonds will be break with it. Actually, when converting solid into a liquid, actually not all the intermolecular bonds may break with it. Some intermolecular bonds remains unchanged. But when a liquid is converted into a gas, what will happen? Definitely all the intermolecular bonds should break. All the intermolecular bonds should break. So as a result of that, all the intermolecular bonds will break with it. As a result of that, all the intermolecular bonds. Then what will happen? Then this liquid phase will be converted into a gas state. Those gas particles have random motion. Gas state. Is that clear? If it is clear, please raise your hand. Please raise your hand. Okay. Okay. So if you can consider about the temperature change during this process, temperature change. If you consider about the temperature change during this process today, suppose this is heat supply heat and this is temperature. So initially temperature increases with heat today. Initially temperature increases with heat and මේ point එක මම ඕන එකක් වෙන්න පුළුවන්. Temperature increases with heat. Then after that, this solid material will convert it into liquid material. That means there will be a phase change. Okay, there will be a phase change. There will be a phase change. So during this phase change, the temperature should be constant. The temperature should be constant during this phase change. Is that clear? If it is clear, please say, raise your hand. During this phase change, although we supply heat, Q1 to Q2, the phase change, during the phase change, temperature is a constant because all the supply heat is used to break intermolecular bonds. Actually, heat is not used to increase the kinetic energy. As there is no increase of kinetic energy, we cannot see a temperature variation. Then again, now the solid is totally converted into liquid putty. Now again, temperature increases with heat putty. Then after certain time, this liquid material start to break their intermolecular bonds. Then again, this process is required heat energy, therefore it absorbs heat putty, but that absorbed heat is totally utilized to breaking intermolecular bonds. Then again, there is no any heat change. So temperature, no any change in temperature. This is heating. And you have to understand this thing. Puthe. In this case, when please listen to this very carefully. This is very, very important thing. When converting a solid into a liquid, actually not all the intermolecular bonds are break. Some intermolecular bonds can be break, but some are remain unchanged. Therefore, energy required to break those intermolecular bonds relatively low. Low means actually it is a very high energy, but compared with this process, Puthe, if you compare with this process, in this process we have to break all the intermolecular bonds. That means the number of bonds to be break in this situation is higher than the number of intermolecular bonds break in this situation. Therefore, energy required to break intermolecular bonds is higher in this case than this case. Is that clear? If it is clear, please raise the hand. I need responses from everyone. Hand the Dinit, Hasindu, Shashindu. Again, මෙතනදී අපිට absorb කරන heat එක වැඩි පුතේ මෙතනට වඩා. ඇයි? මෙතනදී break කරන්න ඕනේ bonds ගාන වැඩි. අය හැම bonds එකක්ම break කරන්න ඕනේ. මොකද ඔක්කොම මෙයා gas board කන්වර්ට් කරන්න එපා. ඒ නිසා හැම intermolecular bond එකක්ම break කරන්න ඕනේ. හැබැයි මෙතන intermolecular bonds එච්චර break කරන්න ඕනේ නැහැ. Therefore, heat required to this process is higher than the heat required to this process. That means latent heat. Normally we call this heat as latent heat. Latent heat corresponding to this phase change is lesser value, but latent heat required to this process should be a higher value. And negative na tussa. එහෙනම් මේ latent heat එකයි මේ latent එක compare කරනකොට මේ latent heat එක වැඩි කියන එක තේරෙනවා නේද තුස්ස? පැහැදිලිද නේද සමහර? Very good. Very good. Right. So after that again, this can be increased. අපි මෙතනින් එහාට ඕනේ නැහැ කියන්නේ gas වෙනවනේ. මෙතන පුතේ මොකද්ද මේක solid to liquid. Solid to liquid. So this phase change is equal liquid to gas. Pute latent heat related to this process is called as latent heat of fusion. Latent heat of fusion. Latent heat of fusion. And this temperature is called the melting point. The melting point. You know that thing. The melting point. This temperature is called the melting point of the substance. Melting point. And the latent heat related to this process is called latent heat of vaporization. Latent heat of vaporization. Latent heat of vaporization. And this temperature, what is the name of this temperature? What is the name of that temperature? Can you tell me? What is the meaning? What is the name of that temperature? Yes, very good lesson. It should be the boiling point. Oh no, it should be the boiling point. So this is the boiling point. It should be the boiling point. ඒකනේ පුතේ අපි කියන්නේ අර ස්ට්‍රීම් එකට එහෙම අතර තිබ්බොත් එහෙම ලොකු ඩැමේජ් එකක් වෙනවා කියලා. ඒ මේ ස්ට්‍රීම් එකේ මේ තියෙන ලේටන්ට් හිට් එක ගොඩක් වැඩි. මොකද මේ ගෑස් එක ලික්විඩ් එකක් වේපර් වෙනකොට ඒකට ඉන්කෝපරේට් වෙලා තියෙන මේ හීට් එක වැඩි ලේටන්ට් හිට් එක. ලොකු ලේටන්ට් හිට් එකක් තියෙනවා. හරිද? ඒක නිසා අර ස්ට්‍රීම් එකට අපි එක්ස්පෝස් වුණොත් එතන තියෙන ඩැමේජ් එක ගොඩක් වැඩි. හරි? හරි. Okay. So you can ඔය අද ඩේට් එක දාගෙන පුතේ මේක හදන්න. Don't draw the graph, just draw this process. Hello. Once you complete writing, please let me know. I finish. Okay. There are this. Once a phase change is occurred, once a phase change is occurred, once a phase change is occurred, come on. The new phase, the new phase starts to act as a new material, fresh material. Starts to act as a fresh material. So, if we supplied heat further, so if we supplied, if we supply, if we supply, if we supply heat further, the inner particles absorb that heat. The inner particle will absorb that heat the inner particle will absorb that heat to change their kinetic energies. To change their kinetic energies. Therefore, the previous process, will be repeated again. Will be repeated again. Write in another paragraph. When converting a liquid into a gas, when converting a liquid into a gas, when converting a liquid into a gas, all intermolecular bonds should break. But when converting a solid into a liquid, 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 the number of intermolecular bonds required to break, the number of intermolecular bonds required to break is relatively smaller than the above number. Is relatively smaller than the above number. You they write this one under that. Therefore, heat energy required to convert liquid into a gas is higher than the heat energy required to convert a solid into a liquid. So this latent heat is called latent heat of vaporization. Okay. Therefore, the latent heat of vaporization, the latent heat of vaporization is higher than the latent heat of fusion. And okay, write this one and these two. Then after that, draw this graph. Healthy. I finish. Healthy. Once you finish, please give me a thumb. Finish na. Again. Oh, the graph at point. Once you complete that thing, you have to draw the graph. Graph at point. Graph at एक का complete ना तो उसका graph at एक का complete ना. If you need more time, please give me a thumb. Time में बोलना पड़ेगा. लगता है मारा. अरे इतना कहने पे बोला बोलू दे बीर दी रखने के है. आंसर का करना आ गया हुआ. Okay, okay, thank you. නැවත එනම් මම ඒක දැම්ම නැත්තේ ඒක මම තව අපි ඩිෆයින් කරේ නැහැ නේ කියලා පළවෙනි එක ඉනිෂියල් ටෙම්පරේචර් මම ඩිෆයින් කරේ නැහැ. සමහර මැටීරියල් තියෙන පුළුවන් 0 වලදී ඒක ගෑස් එකක් වෙන අවස්ථා තියෙනවා. දැන් අපි කාබන් ඩයොක්සයිඩ් ඔක්සිජන් වගේ ගත්තොත් එහෙම ඒක 0 වලදී ගෑස් එකක් නේ. හරිද? දැන් ඒ වගේ තැනකදී මට ඉතින් 0 වල පටන් ගන්න බෑනේ. ඒ නිසා මේක අර මේ රෆ්ස් මේ graph එකක් නිසා මම මෙතන 0 වලට මාක් කරේ නැහැ. දැන් අපි වෝටර් ගත්තත් 0 වලදී ඉන්නේ ලික්විඩ් ෆේස් එකක් තිබුණේ. හරි. ඒ නිසා මැටීරියල් එකෙන් මැටීරියල් එක 0 වලදී සොලිඩ් එක තියනවද කියන එක ඩිපෙන්ඩ් වෙනවා. හරිද? ඒ නිසා මේක 0 වලදී හරියටම මම මෙතන දැම්මේ නැත්තේ මේක. හරි. ඒක වෙනස් වෙන්න පුළුවන් නිසා. Thank you. ඒ කියන්නේ 0 වලදී මැටීරියල් එක එක්සිස්ට් වෙන මැටීරියල් තියෙනවා නැතිව තියෙනවා. එක්සිස්ට් වෙනවා. ඒක 0 වෙනකම් පටන් ගත්තා කියලා ප්‍රශ්නයක් නෑ. හරි. එක්සිස්ට් වෙන්නේ නැත්නම් ඉතින් ඒක 0 දී අපි පටන් ගන්න එක එච්චර හරි නෑ. ඒ නිසා දෙකටම හරියන විදිහට තමයි මම කොමන් ග්‍රාෆ් එකක් හැදුවේ. අනික මම ටෙම්පරේචර් එක ස්කේල් එක දැම්මෙත් නෑනේ. ඒතර ටෙම්පරේචර් එක ස්කේල් එක සෙල්සියස් වුණා. හරි එතකොට 0. හැබැයි මේ කෙල්වින් වල ජීවිතේ 0 වලින් පටන් ගන්න බෑ. කෙල්වින් වලත් සාමාන්‍ය කියන්නේ ඇබ්සලූට් 0 එක අපි එතනට රීච් කරන්න බෑ සාමාන්‍යයෙන්. අපි ඇබ්සලූට් 0 එකේ පටන් ගන්න නැහැ නේ වැටිංගල. ඒ නිසා සාමාන්‍යයෙන් මේ ටෙම්පරේචර් ස්කේල් එකක් තමයි මේක නිසා. Okay, Shari. Okay, Vijay. නෑ වෙනස් වෙන්න පුළුවන් පුතේ. රේට් එක වෙනස් වෙන්න පුළුවන්. අපි ඒවා කතා කරන්නේ ඉස්සර රේට් එක වෙනස් වෙන්න පුළුවන්. T ඉන්ක්‍රීස් කරන රේට් එක වෙනස් වෙන්න පුළුවන්. මොකද දැන් එකක් solid material එකක් ඊට පස්සේ liquid material එකක් නෙමෙයි. එතකොට solid material එකේ තියෙන properties සහ liquid material එකේ තියෙන properties දෙක. ඒ නිසා අනිවාර්යෙන් වෙනස් වෙන්න පුළුවන්. වෙනස් විය යුතු වෙනස් වෙන්න පුළුවන්. හරි. Okay. Shall I start? බලමු පුතේ. මේ suppose this is a material. Okay. Putte, if we give a heat energy to this material, the ability of absorbing this heat energy varies from material to material. Putte. Some material can absorb heat, right? Absorb heat in very quickly as well as in large amount. But some materials cannot absorb heat that much of large amount because it can change their, it can cause to change their phases. Therefore, material to material heat absorption, the ability of heat absorption may vary. Not only absorption but also heat releasing. Actually, some materials can absorb as well as release heat. Heat energy can be released from those materials. Right? Therefore, releasing or absorption of heat energy varies from material to material. Now we are going to analyze what are the factors that can affect to that ability. But remember, now we are going to consider heat absorption without any phase change, because if we want to determine the factors that affect to heat absorption, that varies if there is a phase change, because phase change is a totally different process. Phase change is a totally different process because during heat absorption, initially the kinetic energy, only the kinetic energy increase with the heat. But during the phase change, kinetic energy remains constant. Therefore, during phase change, kinetic energy does not depend on the T. So that means we cannot take all those processes together. Therefore, we have to divide those two processes separately. We have to separate those two processes and then we can analyze them. Okay. Therefore, we have to analyze what are the factors affecting to heat absorption or releasing without a phase change. Then we can analyze what are the factors that affect to heat absorption or releasing during a phase change, because those two processes are two different processes. During one process, only kinetic energy increases. During another process, kinetic energy remains constant and potential energy varies. Therefore, two processes should be treated separately. And therefore, first of all, we are going to discuss about the affecting factor to heat absorption or releasing without a phase change. Is that clear? If it is clear, please raise the mage argument එක තේරුණා කතා අත උස්සන්න. argument එක තේරෙනවා. නිකම්ම ගත්තේ නැත්තේ ඒක. හරි. මතක තියාගන්න මම heat එක දුන්නා කියලා බලයට heat එක absorption වෙන total process එකට මට equation එකක් build කරන්න බෑ. මොකද total process එකේ එක process එකක වෙන්නේ kinetic energy එක increase වෙන එක විතරයි. ඊළඟ process එකේ වෙන්නේ potential energy එක vary වෙන එක විතරයි. හරිද? ඒක increase වෙන්න පුළුවන් decrease වෙන්න පුළුවන් නමුත් vary වෙන විතරයි වෙන්නේ. හරි. ඒක නිසා මට entire process එකට equation එකක් තනි equation එකක් build කරන්න බෑ. ඒ නිසාම process දෙක වෙන වෙනම හදලා phase change එකක් නැති කොටසටයි phase change එකක් තියෙන කොටසටයි වෙන වෙනම treat කරනවා. Is that clear? Now, our topic. Determine the factors. Determine the factors determine the factors affecting to heat absorption or releasing. Heat absorption or releasing without a phase change. Without a phase change. This is a topic. This is a topic. Underline the topic. Determining the factors affecting. Determining factors affecting to. Determine the factors affecting for absorption or releasing heat energy or thermal energy without a phase change. Correct. Now, look at this one. So, according to this scenario, if we give a heat energy, what happens with it? What can be happen? මොකද වෙන්න පුළුවන්? දැන් phase change එකක් නැහැ. නම් මෙතන phase change එකක් නැහැ. So, if we give a heat energy, what will happen? I dances. If we give a heat energy, what will happen? දැන් මගේ ආගියුමන්ට් එකත් එක ලස්සන මේක හදන්න පුළුවන් පුතේ. මේක ලස්සනට කතාවක් වගේ අපිට හදන්න පුළුවන්. ඒ කියන්නේ මේක නිසා මේක අර ආගියුමන්ට් වයිස් මම හදන්න පුළුවන්. බලන්න ඒක තේරුම් ගන්න. අර ලස්සනට තේරුම් ගන්න පුළුවන්. Yes, absorb the heat. Then what will happen? Yes, listen, yes, that is the correct answer. Internal kinetic energy increases with it. And as a result of the temperature will be increased with it, but හැමලේම ආගියුමන්ට් එකේ යනකොට ඒක මාර ලේසි. හරිද? අර end result එක කියන්නේ නැතුව හැම වෙලේම ආගියුමන්ට් එකෙන් යනකොට මාර විදිහට තේරුම් ගන්න පාසුයි. හරිද? So once we give heat energy, what will happen? This heat energy will be absorbed by those particles. This heat by those particles. Okay. This heat energy will be absorbed by those particles, and as a result of that, what will happen? Kinetic energy of particles increases. Kinetic energy of particle increases. So we can observe that process. We can observe whether the particle absorb kinetic energy or not by difference in temperature. Therefore, as a result of that, temperature increases. As a result of that, temperature increases. Therefore, the amount of kinetic energy absorbed, is directly proportional to temperature difference. Is temperature difference. Is that clear? Therefore, the amount of kinetic energy change, the amount of kinetic energy change, the amount of kinetic energy change is directly proportional to temperature difference. The amount of kinetic energy change is directly proportional to temperature difference. That means if the temperature difference is so high, that means kinetic energy increases in large scale. Is that clear? If you got that one, please raise the hand. Make a table sir. I need responses from everyone. Thank you, Uday. All right. The amount of kinetic energy change, the amount of kinetic energy change means the amount of heat energy, because the total heat energy absorbed is used to change the kinetic energy. Therefore, the amount of kinetic energy change is equal to the absorbed heat energy. It is equal to the absorbed heat energy because the absorbed heat energy is totally utilized to change the kinetic energy only. As a result of that, the amount of kinetic energy change should be equal to the absorbed heat energy. If you got that one, please raise the hand. Then another sir. එහෙනම් මේක තමයි absorb heat energy කියලා කියන්නේ. මොකද absorb heat එක තනිකරම use වෙන්නේ මේකේ. හරි. හරි. Therefore, ලියන්න පුළුවන් මට the absorbed heat is heat energy. Totally utilized to change internal kinetic energy. Therefore, the amount of kinetic energy change should be equal to the absorbed heat. Absorb heat. Absorb or release heat. පුතේ release වෙනත් පුළුවන් දෙකම වෙන්න පුළුවන්. මම මෙතන absorb කියලා දාන්න release heat තේරුම් ගන්න. Absorb heat. Absorb heat energy. And actually, absorb heat energy, we can represent that one as Q, put it as Q. Normally, we represent it as Q, absorb heat energy. Therefore, absorbed heat energy should be directly proportional to temperature difference. Therefore, Q should be directly proportional to temperature difference. Put it. Temperature difference. If you got that one, please raise your hand. Table of the sun. This is the first factor influence to heat absorption. ඔයගොල්ලෝ දන්න දෙයක් මේ කරන්න හදන්නේ. හැබැයි පොඩ්ඩක් වෙනස් විදිහට හරි තර්කය ඇතුලේ. හරි ලොජික් එකකින්. So temperature difference, the symbol of temperature difference is delta theta. Delta theta. Delta theta. Sometimes we call it as theta. Theta or delta theta means temperature difference. Therefore, Q is directly proportional to delta theta. This is number one. Right. Uh, Maybe I can do it. Now you can write down this thing because I need to erase the board. Uh, Okay, I finish. I finish. Oh. දැන් බලන්න පුතේ ඊළඟට. Suppose now there are two materials. Sorry, there are two objects which are made of same material. එකම material. Then one has a lesser mass and other one has a higher mass. One has a lesser mass, but other one has a higher mass. And as they are made out of same material, their densities are equal. Therefore, amount of particle per unit volume is equal. And therefore, if we take a higher mass, the number of particles within this materials increases. So here, sometimes number of particles are lesser. But here, the number of particles are relatively higher because mass is increased. Here, this mass is a lesser value there. So M1 is lesser than M2. Therefore, number of particles in this material is lesser than that of the second material. Therefore, number of particles in one is lesser than number of particles in two. Now, let assume we have to give the same temperature difference. Suppose we need to do same temperature difference for those two materials. Same temperature difference. And that means delta theta in this case is equal delta theta in this case. Suppose the temperature difference need to give for both material are same. That means this one and this one. That's it. Now, look at this one. That means we have to change the kinetic energy of each particle to give this temperature difference. And we need to change the kinetic energies of all of these particles to change this temperature difference, to have this temperature difference. Therefore, we have to give heat energy, we have to give energy to each and every particle of this material to increase their kinetic energies. We have to increase all of them. Therefore, the energy required in this case is higher than the energy required of this case, because the number of particles in this case is lesser than the number of particles in this case. As the number of particles increases, The energy required, increases, Puti. Why? What is the reason? What is the reason? We have to give heat energy. We have to give heat energy to all of these particles to increase their kinetic energies. Therefore, definitely, the number of particles can affect to the amount of heat absorbed. Therefore, in this case, the absorbed heat energy is higher than this case, Puti. Than this case. And that means when mass increases, we need to give more heat energy to change the temperature, to change the kinetic energy. Is that clear? If it is clear, please raise the hand. I need responses from everyone. Hallelujah. Shashmit Hallelujah. Zina. Okay. Okay. First, Boolean first factor, first factor. Then write this one as second factor. Hallelujah. They write on this. Suppose there are two materials. Sorry, suppose there are two objects. Suppose there are two objects made out of the same material. Suppose there are two objects made out of the same material. Made out of the same material, but different masses. Suppose there are two objects made out of the same material, but different masses. As a result of that, the number of particles in the second object is higher than the first object. As a result of that, the number of particles in the second object is higher than the first object. If we need to change, if we need to change the temperature of the object, objects, if we need to change the temperature of the objects in same amount, we should change the kinetic energies of each particle. We should change the kinetic energies of each particle we should change the kinetic energies of each particle. Full stop. As the number of particles is higher in the second object, as the number of particles is higher in the second object, as the number of particles is higher in the second object, it requires more heat energy. It requires more heat energy than the object one. Than the object one. Therefore, Q directly proportional to mass. We call it as M/A. Therefore, Q is directly proportional to it. Like that. Okay, then right, the third factor. Third factor. Suppose there are two objects today. There are two objects with equal masses. That means, suppose their number of particles are equal. Sorry, equal masses, but different in material. Material type is different. And අපි same mass තියෙන නිසා මම ගන්නම් අපි මේක okay. Masses are same. Masses are same. And we need to change the temperature difference evenly. That means the temperature difference in object 1 and object 2 are same. That means kinetic energy increment should be same. And should be same. That means we need, suppose initial temperature is 30. Both the initial temperature of both material is 30. We need to raise the temperature of both material up to 40. Up to 40, we need to change. That means we hope to change the temperature by same amount. And masses also equal. Suppose the intermolecular bond, strength of intermolecular bond is higher in second case than the first one. The strength of intermolecular bonds are higher in case 2 than case 1. That means they are bonded together strongly, Kute. They are bonded together very strongly. So, although we give heat energy, it is very hard to, because they are bonded together very strongly. Therefore, although we give heat energy, it is very hard to change the kinetic energy. And the hill and the අල්ලන් බැඳලා තියාගෙන ඉන්නේ. ලේසි නෑ හෙල්ලෙන්න. ලේසි නෑ හෙල්ලෙන්න. හොද්දට අල්ලලා බැඳලා තියාගෙන ඉන්නේ. හෙල්ලෙන්න දෙන්නම නෑ. හරිද? ඒක නිසා මොකද වෙන්නේ? අපිට එනර්ජි එක දුන්නාම although we give heat energy, it is very hard to change the kinetic energy. Therefore, if you want to change kinetic energy, you have to give more heat energy in this case. But here, it is very loose material put in. If we give very little heat energy, the kinetic energy can be increased. It can be increased very easily. It can be increased very easily. Therefore, in this case, it is very easy to increase temperature, but here it is very hard to increase temperature. Therefore, this material requires less heat energy. This material requires relatively high heat energy. Therefore, according to the type of material, the absorption or releasing heat energy varies with it. And is that clear? If it is clear, please raise your hand. තේරෙනවද තුසන්? එහෙනම් material type එක තමයි නම් ඊළඟ fact එක. පැහැදිලිද? I need responses from everyone. ඔන්න හැමෝගෙම respond එක තියනවා කියන්න. මොකද මේ තේරුම් නැත්නම් මම අයපාරක් කියනවා. තේරුම් නැත්නම් මම අයපාරක් කියනවා. Okay. Thank you. Okay. The third factor. Third factor, do this. පුතේ මේ අපිට එක්ස්ට්‍රා ක්ලාස් එකක් පුළුවන් Thursday. Thursday from 5:30 a.m. to 8:30 a.m. 3-hour class. 8:30 and 7:30 කරනවා. මම පුළුවන් නම් පුළුවන් කට්ටිය අතොස්ස. Any extra class on Thursday? Can, no? Hold on. බැරි අය පොඩ්ඩක් අනිත් ඔය කට්ටිය දැන් අතපාද මට බැරි අය පොඩ්ඩක් කියන්න. බැරි අය. Machine බැරි. Thursday බැරි. අපි Tuesday වවක් තියෙනවා. Then Friday? Friday? During the same time, Friday. Cannot. Yes, everywhere. Friday bැරි. Thursday. Just what can I mistake from justify it. Tuesday වරුන් හැබැයි තව හීට් වලට තව එක්ස්ට්‍රා ක්ලාස් එකක් දාගන්න පුළුවන් නම් හීට් ලෙසන් එක තව එක ක්ලාස් එකක් දාගන්න පුළුවන් නම් කරන්න. මොකද එතකොට මට නෙක්ස්ට් වීක් වෙනකොට ඇකඩමික් වල ප්‍රෙෂර්ස් ටිකක් අපිට කරන්න ඉවර කරගන්න පුළුවන්. ඒතකොට තමයි පටන් ගන්න පුළුවන්. හරි කවන්නේ. Okay, they right under this. Help them. They right under this. Suppose there are two equal masses made out of same, so different materials. Suppose there are two equal masses made out of different materials. Now there can be number of particles can be changed with it. Same material එක මෙයාගේ density වෙනස් නේ. Density වෙනස් වෙනකොට ඉතින් අර number of particles ගන්න වෙනස් වෙනවා. ඒකත් එක්ක Suppose there are two equal masses made out of different materials. Suppose there are two equal masses made out of two different materials. They are supposed to heat up to an equal temperature difference. They are supposed to heat up to an equal temperature difference. As they are two different materials, the strength of intermolecular bonds, comma, number of particles per unit volume, comma, lattice structure, lattice structure, lattice structure. Etc. May vary, may vary. Yeah. Actually, I have described only one factor, but there are so many factors due to two different materials. Correct? Yeah. There are so many factors for it. There are sometimes the lattice structure, actually, not sometimes, actual lattice structure varies from one material to one material. Some lattice structure have very, actually, those are some, there are some obstructions in lattice putin. So due to those obstructions, material cannot change their kinetic energy easily. On the other hand, number of particles can be changed from material to material, although the mass is equal. Therefore, there are so many factors. There are so many factors vary from material to material. So, due to those complicated reasons, the amount of heat absorption the amount of heat absorption to change equal kinetic energy may vary. And therefore, the type of material will affect to the amount of heat absorption. The amount of heat absorption. Is that clear? If it is clear, please raise the hand. Okay, there are this one. Due to those reasons, due to those reasons, the amount of heat absorption, the amount of heat absorption, the amount of, sorry, sorry, reduced person, the ability of heat absorption, the amount, no, the ability of heat absorption, the ability of heat absorption, the ability of heat absorption varies. They write in another paragraph. Now, factors තුනම කතා කරා. So those are the three factors that affect to the ability of heat absorption. Ability of heat absorption. They write on that. Therefore, the ability of heat absorption depends on the following factors. Therefore, the ability of heat absorption depends on the following factors. the type of material. Therefore, therefore, Q depends on three factors. Q depends on three factors: M, delta theta, and material. Pute, among those three factors, material, actually, we cannot measure that factor. No, we cannot measure that factor. It is not a physical quantity, no, because it cannot be measured. Material, how to measure material? Material, we cannot get a numerical value for material. So actually, there may be such cases when we analyze it. When we analyze in affecting factor to a certain physical quantity, there may be some factors that cannot be measured. But those factors influence to this physical quantity, but cannot be measured. See, in such cases, Puthe, we are going to build a relationship without considering this factor, but considering these two measurable factors. Okay. මේක measure කරන්න බෑනේ. measure කරන්න බැරි එකක් ආවොත් එහෙම අපි measure කරන්න බැරි එක පැත්තකින් තියාගෙන measure කරන්න පුළුවන් ටිකත් එක්ක අපි relationship එක කරනවා. Therefore, we can keep this one separately and take the measurable two factors and build a relationship. And then it is very clear, okay? It is very clear. Q directly proportional to M. When M increases, Q increases, okay? As well as Q directly proportional to delta theta. We have determined that thing. When delta theta increases, temperature difference increases, the required heat increases, okay? Required heat increases. So, using those two relationships, I can say from 1 and 2. Okay, if any physical quantity is separately proportional to another two, then that physical quantity depends on or directly proportional to the product of those two. Now this is a relationship, Pute. So this relationship should convert it into an equation. So how to convert this relationship into an equation? By taking a constant. Actually, there's a theory behind that one. We have discussed the thing in unit dimensions. Therefore, no need to repeat that thing. Why we insert a constant? Actually, we have discussed the reason to that one. Right? Okay. Therefore, this relationship can be converted into an equation by introducing a constant. Therefore, Q should be equal C M delta theta. Okay, this is the constant of proportionality. Constant of proportionality. A proportional constant. Look at this one. If you build an equation, all the factors affecting to Q should be in this equation. If we build an equation, all the factors affecting to Q should be here. Now it is very clear, M is here, delta theta is here, and there's another one, C. There's another one, C. This is a constant, but it is a foreign physical quantity, no? Uh, Therefore, definitely, this constant should represent the other factor which is not considered during the derivation. Therefore, definitely, this C depends on the other factor which is not considered during the derivation. If you got my explanation, please raise the hand. තේරුණා පුස්සා. මේවා පුතේ හරියට මේවා අතරම මේවා තේරුම් ගන්න තියෙනවද කියලා එක්සෑම් එකට අහලා තියෙනවා. මේවා එක්සෑම් එකට අහලා තියෙනවා. මොකද මේ ඩෙරිවේෂන් එක අපි මේ කතන්දර කරපුදී උත්තර තේරුම් ගන්න ඕන. එකපාරක් අහලා තිබ්බ මෙන්න මේක මොනකද ඉක්වේෂන් එක. මේක හරිය නැත්තම් හුක්ස් ලෝ එකේ තියෙන එකද මොකද දෙකේ එකක්. මේ constant of proportionality දීලා මෙයා depend වෙන factors අහලා තිබ්බා. dependent factors. දැන් example එකක් විදිහට මේක හිතන්නකෝ. හරිද? නෑ මම මෙතන ගත්තේ පුතේ මේ අපේ C කියලා ගත්තේ constant එක කියලා ගත්තේ අපේ equation එක අපි දන්නේ දැන් ඕක දන්නවනේ මේ MC theta කියන equation එක. MC theta කියන equation එකේ මේ C තියෙන නිසා තමයි මම C කියලා ගත්තේ. මේක මේ C කියලා කියන්නේ ඇත්තටම අපේ මේ standard symbol. හරිද? මේකට කේ නෙවෙයි අයන්න දාගන්න ඈන්න දාගන්න ලියන්න දාගන්න ඕන දෙයක් දාගන්න ප්‍රශ්නයක් නැහැ. හරිද? හැබැයි මේක ස්ටෑන්ඩඩ් සිම්බල් එක. මේ ස්ටෑන්ඩඩ් සිම්බල් එක ඉස්සරහා දාන්න. හරි. ඒ නිසා මේකට දාන අකුරගෙන පොරි වෙන්න එපා. හරි. ඊළඟට මම කතා කරපු විදිහ නෙවෙයි. අතරම එක්සෑම් එකේ මේක අහලා තිබ්බා. පුතේ මේ මට මතක විදිහට එක්ක මේ ඉක්වේෂන් එක නැත්තම් මේ අර හුක්ස් ලෝ එකේ ඉක්වේෂන් එක දෙක එකක්. ඒකේ මේ C ෆැක්ටර් එක ඩිපෙන්ඩ් වෙන දැන් C කියන්නේ මේ කොන්ස්ටන්ට් එක ඩිපෙන්ඩ් වෙන ෆැක්ටර්ස් ආපු. හරි. ගොඩක් ළමයි කරලා තිබ්බේ මොකද්ද? C කියන එක සබ්ජෙක්ට් කරා මේකේ. හරි C කියන්නේ මොකද්ද? හරි. Q over MC sorry M theta හරි M theta then Q depends on C depends on Q, M and theta. ඔන්න කරපුවා. අයි මේ ඩෙරිවේෂන් එක දන්නේ නැහැ කොහොමද ඩෙරිවේෂන් එක කියලා දන්නේ කරේ එහෙම. හරිද? මෙහෙම කරන්න පුළුවන්. හරිද? අපි මොකක් හරි ඉක්වේෂන් එකක් තියෙනවා නම් ඉක්වේෂන් එකේ මොකක් හරි එකක් ඩිපෙන්ඩන්ට් ෆැක්ටර්ස් අහනකොට ඒක සබ්ජෙක්ට් කරලා වැඩේ කරන්න පුළුවන්ද? බෑ. මේක තනිකර වැරදි. තනිකර වැරදි. අපි ඉක්වේෂන් එක බිල්ඩ් කරන්න පුතේ මෙන්න මේ පැත්තේ left hand side එකේ තියෙන physical quantity එකට influence කරන්න පුළුවන් factors ටික තමයි right hand side එකේ තියෙන්නේ. හරිද? අපි හොයන්නේ ඒක. left hand side එක depend වෙන factors ටික තමයි මෙතන තියෙන්නේ. අපි equation එක කියලා කියන්නේ අන්න ඒක. එහෙම නැත්නම් ආර මේ left hand side right hand side එකේ තියෙන මොකක් හරි physical quantity එක subject කරලා මෙතනට ගන්න බෑ. දැන් එහෙම උදාහරණයකට මේක වගන්නකෝ. M ගන්න. M කියන්නේ මොකක්ද? M කියලා කියන්නේ එහෙම Q over C theta. අපි මොකක් හරි mass එකක් කියන එක depend වෙනවා පුතේ. heat එකටයි C ටයි theta mass එක. එහෙම හිතන්න පුළුවන්. තනිකර වැරදිද නේද? දැන් අපි ගත්තොත් S equal UT කියන equation. දැන් ඔයා මේකෙන් T කියන එක සබ්ජෙක්ට් කරන්නේ. T කියන එක සබ්ජෙක්ට් කරොත් S over U. ඒ කියන්නේ time එක depend වෙන්න ඕනේ displacement of මේ velocity. හරි. ඒ කියන්නේ අපි මේ යන ඕනම time එක displacement of velocity depend වෙනවා. ඒක හරිද? නෑ නේද? Totally wrong. හොඳට මතක තියාගන්න equation එක build කරනකොට build කරන්නේ left hand side එකේ තියෙන physical quantity එකට බලපාන factors ටික තමයි පුතේ right hand side එකේ තියෙන්නේ. ඒ වගේ වෙලාවක right hand side එකේ තියෙන factor එකක් subject කරලා උට බලපාන්නේ මේවා කියලා කියන්න බෑ. ඒක වැරදි. මොකද අපි එයාගේ එහෙම බැලුවේ නේ. එයාගේ බැලුවේ නේ. ඒක නිසා මේකට බලපාන මෙන්න මෙයා dependent factors. මෙයා dependent factors ඔයාලට තේරුම් ගන්න ඕන නම් ඔයා තේරුම් ගන්න ඕනි මෙයාට බලපාන නැත්නම් මෙයා affect වෙන නැත්නම් මෙයාට influence කරන්න පුළුවන් ඔක්කොම factors මොනවද තියෙන්නේ. මේ ඔක්කොම factors වලින් මේකේ තියෙන මොනවද කියලා බලන්න. දැන් මෙතන ඔක්කොම factors තුනක් තියෙනවා. තුනෙන් දෙකක්ම මෙතන තියෙනවා. හරිද? එහෙනම් ඉතිරි ඒවත් එක්ක තමයි මෙයා depend වෙන්නේ. ඉතිරි ඒවත් එක්ක තමයි මෙයා depend වෙන්නේ. දැන් මෙතන නම් තියෙන එක factor එකයි පුතේ. එහෙනම් මෙයා depend වෙන්නේ මේ material කියන factor එකත් එක්ක තමයි. දැන් අපි ඉස්සරහට මේ කතා කරන ඔය convection වගේ කතන්දර වලදී convection ගත්තොත් මේ පුරා factors වල depend වෙනවා. හැබැයි equation එකේ තියෙන්නේ factors එකයි නැත්නම් දෙකක් තියෙනවා කියලා. එච්චරයි. එහෙනම් ඊටු ඔක්කොම factors මත අර constant එක depend වෙනවා. ඒ නිසා මොකක් හරි constant එකක් depend වෙන factors හැමෝත් එහෙම හොඳට මතක තියාගන්න. You have to consider what are the factors influence to this physical quantity. Then what are the factors available among those factors? Then this physical quantity depends on the remaining factors because all the factors should represent this equation because this is the equation for this is an equation. Therefore, in this equation, all the factors should be there. All the factors should be there. Therefore, definitely, this equation should have all the factors. Or otherwise, there may be some equation. Sometimes we can keep constant some factors for it. And then we can derive the equation. එහෙමත් කරනවා. සමහරවිට මොකක් හරි දේවල් constant කරගෙන අපි ඒ කියන්නේ factor එක මට calculate කරන්න බැරි නම් අපි ඒක constant විදිහට තියාගන්නවා. constant විදිහට තියාගෙන අපි equation එක build කරනවා. එතකොට මේ factor එක ගැන හිතන්න ඕනේ නැහැ. factor එක අපි අයින් කළා තියෙන්නේ. constant විදිහට තියාගත්තොත් ඒ factor එක අයින් කළා තියෙනවා. එතකොට මේ factor එකත් එක්ක මෙයා depend වෙන්නේ නැහැ. නිසා හොඳට තේරුම් ගන්න. You have to understand how we derive this equation. අනේක කියන්නේ you cannot memorize this equation only. කටපාඩම් කරන්න තරක් මේක බෑ. හොඳට මතක තියාගන්න මේ equation එක derive කරපු විදිය අනිවාර්යයෙන් තේරුම් ගන්නවා. Otherwise, you cannot give answers for some equations, some questions. Yeah. If you got my explanation, please let me know. තේරුණා තුසුන්. පැහැදිලි නැත්නම් තුසන් ඕන කිව්වේ. යොක් කතන්දරයක් කියනවා. හරි. Okay. Then try these three factors. And right up to this. Right up to this one. Don't write this one. Don't write this one. Okay, they write this one. They write this one. Here, material is not a measurable quantity. Here, comma, material is not a measurable quantity. Material is not a measurable quantity. Therefore, therefore, we can build a relationship with the other two factors. With the other two factors. Okay. They're right from here to here. They're right from here to here. Sorry, need to write down. Okay, there are this. The above equation should represent all the affecting factors, all the affecting factors of Q. But M and delta theta are in the equation, but m and delta theta are in the equation. Write another para. Therefore, the constant of proportionality, see, the constant of proportionality, simple C, okay? This one should be simple C. Therefore, the constant of proportionality, simple C. Therefore, the constant of proportionality, simple C, should represent the other factor. Should represent the other factor. Should represent the other factor. Therefore, C depends on simple C. Therefore, simple C depends on the type of material. The type of material. Therefore, we can rearrange the equation as this today. Q equal MC delta theta. So this is our regular equation. You know this thing to our syllabus. This C is called the specific heat capacity. Specific heat capacity of that material. C is called the specific heat capacities. Capacity, the specific heat capacity of that particular material. Therefore, the specific heat capacity depends on the type of material. Therefore, the specific heat capacity depends on the type of material. The type of material. Okay. You can underline it. බලන්න පුතේ මෙයා යුනිට් එක unit of C. So you know this is heat energy. Q equal MC theta නේ පුතේ. MC theta නැත්නම් මෙතන එකක් කවන්නේ. හරි. Q is an energy. Q is an energy. Heat or any energy. Heat or any kind of energy is measured by joule නේ පුතේ. Therefore, this is measured by joule because it has energy. This is a mass, therefore it is measured by kilogram, and this is the temperature. It is measured by Celsius or Kelvin. Celsius or Kelvin. Therefore, if you bring these two physical quantities to this side, these values will be will be minus power. These powers will be minus powers. And therefore, unit of C is equal joule per kilogram per Celsius. Joule per kilogram per Celsius or joule per kilogram per Kelvin. Both passing. minus 1. Yeah. So this is the unit of C පුතේ. හරිද? ඒක තමයි. Have finished writing? Okay, now we can define. Now we can define C පුතේ. Now we can define C. Actually, when you are determining the affecting factor, you cannot subject. But when you are defining means defining this unit with according to this unit, we can define the physical quantity. Definition එකක් දෙන්න පුළුවන්. හැබැයි affecting factors හොයන්න බෑ. හරි බලන්න. So when we are defining a physical quantity, you can subject it. You can subject it. You can subject that physical quantity. C is equal. මෙන්න මේක තමයි දැන් පටලවා ගන්න. තව පටලවා ගන්න මොකද මේක සබ්ජෙක්ට් කරනවානේ. ඒක නිසා ඒකයි මේක පටලවා ගන්න. මේක අරක පටලවා ගන්න. Q equal M delta T. So when you are defining the physical quantity, you can subject it. Yes, then you can equate the denominator. You can equate the denominator to 1. If denominator is 1, the numerator will equal C2. If denominator is equal 1, numerator is equal the left hand side. Therefore, if the denominator is 1, then the numerator is equal the left hand side. ඒක තමයි අපි ගන්න logic එක. If the denominator is 1, numerator is equal left hand side. And ඒක දිහා බලද්දී දැන් define කරන්න පුළුවන්. That means C is equal to the energy required to raise 1 kilo to raise the temperature of 1 kilogram of a material by 1 unit. That is equal C. The definition of C. The energy required to raise the temperature of 1 kilogram of a material one unit is called the specific with the heat energy, the heat energy required to raise the temperature of 1 kilogram of material by 1 unit is called the specific heat capacity of that material. So that is the definition. Have a good day. Have finished writing? Alright. මතක තියාගන්න මේ heat lesson එක කරනකොට මම හොඳට ආයපාරක් ඔයගලන්ට කියන්නේ මේ heat lesson එක කියලා කියන්නේ පුතේ අතන මෙතන තමයි physics අතර මේ start වෙන්නේ. හරිද? මේක හොඳටම understand කරගන්න ඕනේ තේරුම් ගන්න ඕනේ subject එක. ඒක නිසා මේකේ තියෙන theoretical part එක ටිකක් වැඩි. mathematical part එක තියෙනවා. නමුත් mathematical part එකට approach කරන්න ඕනේ තියෙන theoretical part එක ගොඩක් වැඩි. අර මැකනික්ස් වගේ නෙවෙයි අනික මැකනික්ස් වගේ අපිට එකපාරට පේන්නේ නැහැ. මේවා ඇතුලේ තියෙන කෙලින්ම හීට් ගත්තට පස්සේ ඒක අනිවාර්යෙන් ඉන්ටර්නල් එනර්ජි එකක් එක්ක සම්බන්ධයි. ඒ කියන්නේ අපිට ඒක පේන්නේ නැහැ අපිට ඒක ඉමේජින් කරන විතරයි තියෙන්නේ. මෙන්න ඔය දෙයක් වෙනවා කියලා ඉමේජින් කරන විතරයි තියෙන්නේ. ඒ නිසා හොඳට මතක තියාගන්න හීට් ලෙසන් කියන මේ තියරි පාර්ට් එක බොහොම ලස්සනට ලොජිකලි අරේන්ජ් කරන්න. ලොජිකලි අරේන්ජ් කරොත් හරියම ලේසියි මේක තේරුම් ගන්න. එහෙම නැතුව පුතේ කොනක් අල්ලගන්න බෑ හරි අමාරුයි. ඇත්ත කතන්දර එක. ඊට පස්සේ හීට් කියන්නේ ළමයි එපා වෙලා. හරිද? ඒ නිසා හොඳට තේරුම් ගන්න. මේක හරියට තේරුම් ගන්න. හොඳයි. Then the next one. පුතේ this is called specific heat capacity පුතේ. Specific heat capacity. There is another physical quantity called heat capacity. Heat capacity. Actually, heat capacity is not another one. Actually, it is created or it is formed by combining these two. That means instead of considering MC product, we can consider it as a heat capacity. This MC product is called heat capacity. Heat capacity. And the symbol is capital Z. ඔන්න ඔක තමයි ළමයි ඊළඟ පටලවා ගන්න. සිම්පල් කැපිටල්. ඔක ඉතින් වෙන සිම්බල් එකක් දුන්නා ලේසි. C කියන වර්ඩ් මේක ගත්තට පස්සේ ඒකට ඒක සිම්පල් එකයි කැපිටල් එකයි දෙක මේක වගේ. ඒ නිසා ඔක හරි complicated වෙනවා මම සමහරවල් පටලවා ගන්නවා. හරි. heat capacity. Actually heat capacity capital C is called MC product එක තමයි අපි කියන්නේ. Actually, this is may defined for mathematical purpose, but sometimes instead of giving M and C, we can give heat capacity. Therefore, in such cases, we do not need any additional information, because if you want to give, if you want to calculate this, if you want to calculate heat energy using this equation, we need to have these three factors. So instead of three factor, it can be reduced up to two by considering MC product as a one single factor. මේ නිසා මේක mathematical purpose එක විතරයි මේක use කරන්නේ. ඒවට heat capacity කියලා fact එකක් නෙමෙයි තියෙන්නේ. අතරම එතන MC product එක තියෙන්නේ. Right? Okay. Therefore, Q is equal C, capital C, delta theta. C theta. Therefore, we can subject the subject C. So if I subject C, that is equal Q over theta. Q is measured by joule. This one is measured by Kelvin. Therefore, the unit of heat capacity is equal joule per Kelvin. Joule per Kelvin. Joule per Kelvin. Okay. There are a topic heat capacity, capital C. Heat capacity, capital C. Capital C only. Then we can define heat capacity. Heat capacity definition. Capital C is equal Q over theta. So you need to equate this one to 1. That means heat capacity is the heat energy required to change the temperature of a material by 1 Kelvin or 1 unit. The heat capacity is the energy, the heat energy required change the temperature of a material by 1 Kelvin. Is that clear? If you got that one, please raise that there on to say heat capacity calculation. I need responses from everyone. Hello, Bhupesh. Okay, there are this one, heat capacity. Maybe I can. Okay. Have finished writing? Yeah. Yeah. Actually, in today's lesson, we have derived two equation. One is MC theta, Q equal MC theta, and Q equals C theta. Q equals C theta. Okay. If you have any questions regarding today's lesson, please raise your hand or please give me your comment. Okay, Nana. Sorry, marker question at the hand. Okay. Others, தெரியும். கொஞ்சம் கட்டி. கொஞ்சம் கட்டி. Yeah. Okay. Very there, Tusan. Very there, Tusan. If you got all the things, please raise your hand. Thank you. Okay. Then we can complete today's lesson. When we can complete today's lesson. Tuesday we will have a full day class. Okay. The initial lessons will be waves. Then the evening lessons. Evening lessons means actually there might be two sessions for light because it will be helpful for your next term text exam. Okay, therefore there may be two sessions in lights. Ada අපි full day class එකකට 3 sessions තියෙනනේ පුතේ 3 sessions එකකින් first session එක අපි waves වලට දාමු ඊළඟ session එක අපි lights වලට දාමු lights වල sessions දෙකක් එතකොට එනවා. හරි. Okay. Then we can complete today's lesson. Everyone have a good time. Okay. Everyone.
Thank you, sir. Good night, sir.
Welcome, Puteh. Welcome. Good luck, Puteh. Welcome.